Far beyond the edges of our solar system, where the sun's light fades to a ghostly flicker and the void stretches into an incomprehensible emptiness, Voyager 2 drifts through the interstellar night. For decades, it has sailed in silence, a solitary artifact of human ambition, carrying our hopes etched onto a golden disk. Launched in 1977, it was meant to graze the outer giants, Jupiter, Saturn, Uranus, Neptune, before slipping into the cosmic deep, a fading beacon of our existence. Its signals grew faint, its power dwindled, and its story seemed destined to end in quiet obscurity. But something has shifted. In the spring of 2025, Voyager 2 did something impossible. It turned. Not a random drift, not a mechanical failure, but a deliberate, precise reorientation. And then it began transmitting something new, something that wasn't in its programming, something that wasn't human. A signal, structured and relentless, pulsed through the darkness, carrying data that has left scientists speechless. This isn't a malfunction. It's not a cosmic echo. It's something else entirely. And what Voyager 2 has uncovered may unravel everything we thought we knew about the universe, our technology, and perhaps ourselves. Because Voyager didn't just turn back. It turned towards something. And what it found has stopped the world. When Voyager 2 left Earth, it was a marvel of engineering, a compact probe built to withstand the harshest environments of space. Its mission was simple yet audacious: explore the outer planets, gather data, and then drift forever into the interstellar medium. It carried a golden record, a time capsule of humanity's voice, music, greetings, the sounds of waves and wind, meant for any intelligence that might one day find it. After its final encounter with Neptune in 1989, it crossed the heliopause in 2018, entering the realm where solar winds give way to the cosmic tides. For years, its signals were routine, a slow trickle of telemetry from a machine running on fading plutonium. Scientists at NASA's Jet Propulsion Laboratory monitored it out of duty, expecting little more than a gradual fade to silence. But in March 2025, a faint anomaly appeared in the data stream. At first, it was barely noticeable. A slight delay in the signal, a fraction of a second off. Engineers chalked it up to cosmic interference, perhaps a burst of radiation from a distant star. But the anomaly persisted, growing sharper, more defined. It wasn't noise. It was a pattern, a rhythmic pulse embedded in Voyager's transmissions, like a heartbeat echoing from the void. The pattern wasn't random. It carried a structure, a sequence of modulated frequencies that didn't align with any known NASA protocol. When analysts at JPL isolated the signal, they found something extraordinary. It wasn't just a transmission, but a resonance, vibrating at a frequency that mirrored the natural oscillations of Voyager's own systems. It was as if something out there was tuning itself to the probe's internal rhythm, syncing with its decaying power core. By April, the signal had evolved. It began to shift, aligning not with Voyager, but with something far closer to home, Earth's own magnetic field. Specifically, it matched the Schumann resonances, the low-frequency electromagnetic waves that pulse through our planet's atmosphere, a kind of global heartbeat. This wasn't a coincidence. The signal was adapting, mimicking Earth's natural rhythms with a precision that defied explanation. Scientists ran every test they could, checking for solar flares, cosmic rays, even quantum fluctuations. Nothing fit. One researcher, a young physicist from MIT, proposed a radical idea. What if the signal wasn't just reacting to Earth? What if it was responding to us, using Voyager as a conduit to bridge the gap between our world and something far beyond? On April 22, 2025, Voyager 2 did something even more inexplicable. Without any command from Earth, without firing a single thruster, its high-gain antenna realigned itself with laser-like precision. For years, the antenna had been drifting slightly off axis, a natural consequence of the probe's aging systems. Now it locked onto Earth with an accuracy that should have been impossible given its dwindling power. More unsettling, Voyager's dormant instruments, sensors designed for planetary flybys decades ago, began activating on their own. Data packets started streaming back, Not raw telemetry, but compressed, structured bursts encoded in a format NASA had never used. Each packet ended with a distinct marker, a sequence of three interlocking waveforms, like a digital signature etched into the data. Scientists began to whisper about possibilities they dared not say aloud. This wasn't a glitch. It wasn't a hack. It was a message, and it bore the hallmarks of intent, deliberate, calculated, and aware. Then on May 10th, the signal stopped. For 17 seconds, Voyager 2 went completely silent. No telemetry, no carrier wave, nothing. When it resumed, the transmission was stronger, clearer, and carried something new. A data stream that, when decoded, produced a visual pattern. It wasn't an image in the traditional sense, but a mathematical construct, a three-dimensional lattice based on the golden ratio, spiraling inward with hypnotic precision. When rendered, it resembled a map, not of stars or planets, but of something more abstract, a framework of spacetime itself. Voyager's 1970s circuitry couldn't generate this kind of complexity. The data had to have been inserted from an external source. Triangulation of the signal's timing suggested an origin point roughly 4.7 light-years away, near the Alpha Centauri system. But here's the problem. Alpha Centauri emits no detectable signals in any spectrum we can observe. If something was transmitting from there, it was operating beyond our technological reach, or it wasn't in Alpha Centauri at all, but somewhere else, somewhere we can't yet see. As NASA grappled with the implications, a team at the University of Cambridge took a different approach. They fed Voyager's data into a neural network designed to detect linguistic patterns. What emerged wasn't noise or static, but a structured code, a binary language with syntax and grammar. It wasn't human code, not the machine language of the 1970s or the quantum algorithms of today. But it was familiar, echoing the logic of early computing systems while introducing new structures, optimizations that hadn't been invented yet. The code seemed to anticipate Earth's digital architecture, offering solutions to problems we hadn't even defined. One segment of the code, when simulated, optimized a quantum encryption protocol that had stumped researchers for years. The implication was staggering. Whatever was sending this signal wasn't just communicating. It was teaching, upgrading, rewriting the rules of our technology in real time. And it was doing so through a probe we built nearly half a century ago. Then came the astronomical anomaly. In late May, observatories in Australia and Chile reported something unprecedented. 5 stars in a tight cluster near Voyager 2's trajectory dimmed simultaneously for exactly 2.1 seconds. This wasn't a natural phenomenon. No dust cloud, no gravitational lensing could explain it. The dimming aligned perfectly with the peaks of Voyager's signal, as if the stars themselves were part of the transmission, amplifying or relaying it across vast distances. When astronomers mapped the light curves, they found the same triple waveform signature embedded in the stellar flicker. It was as if the signal wasn't just coming from Voyager, but was being mirrored across the cosmos, using celestial bodies as nodes in a galactic network. The question wasn't just who was sending this message, it was who else was receiving it, and why were we only now noticing? The golden record, Voyager's most poetic gesture, took on a new significance. In June, sensors on the probe detected an anomaly in the record itself. The disk, made of gold-plated copper and designed to last 1 billion years, showed signs of electrical activity. Not random static, but a directed current, as if it had been integrated into a circuit. Then buried in Voyager's data stream, analysts found something even more startling: a digital reconstruction of one of the record's tracks, a Navajo chant, originally recorded in low fidelity. The new version was pristine, enhanced beyond the original's capabilities, as if someone had not only heard it, but understood it, refined it, and sent it back. This wasn't a copy or a loop. It was a reinterpretation, a signal that whoever was out there had deciphered humanity's message and was now responding in kind. The thought was inescapable. The golden record wasn't just a relic, it was a beacon, and something had answered. Meanwhile, a faint secondary signal began trailing Voyager's main transmission, lagging by exactly 7.4 seconds. At first, scientists thought it was an echo, perhaps a reflection off a distant object. But when they analyzed the angles, the signal's origin didn't point to any known body. No planet, no comet, no star. It came from a void, an empty patch of space just beyond the Oort cloud. The secondary signal wasn't just mimicking Voyager. It was adding to it, embedding data about our solar system, magnetic fields, orbital paths, even the chemical composition of Earth's atmosphere. It was as if something was using Voyager to scan us, to build a detailed model of our world. The term researchers used was specular mapping, a mirror image, but not of light or matter. It was a mirror of us, our planet, our systems, reflected back through a 48-year-old probe. Then came the neurological effects. Amateur astronomers and radio enthusiasts, listening to Voyager's raw signal through spectrum analyzers, reported strange symptoms: vertigo, memory lapses, a sense of déjà vu that lingered for hours. At first, these were dismissed as psychosomatic, but experiments at a German university confirmed the anomaly. The signal's subharmonics carried a low-frequency wave that interacted with the brain's electromagnetic fields. In controlled tests, volunteers exposed to the signal showed altered neural activity, their short-term memory subtly reshaped. Rats in a lab maze exposed to the same frequency began repeating paths with slight variations, as if their decisions were being nudged. The signal wasn't just data, it was bioactive, capable of influencing thought patterns. Was this an accident, or was something testing the boundaries of our biology? In July, telescopes scanning the Oort cloud detected something solid, a structure, not a natural object, with angular edges and a radar signature that matched Voyager's own materials. It wasn't moving, wasn't rotating, but it was emitting a faint signal that synced with Voyager's transmissions. The object's composition included alloys used in the probe's construction, alloys no longer manufactured on Earth. The hypothesis was chilling. This wasn't an alien artifact. It was a replica, a perfect copy of Voyager 2, built by something that had studied it down to the molecular level. If this was a response, it wasn't just a message. It was a demonstration, a proof of capability. Something out there could not only receive our signals, but recreate our technology, perhaps even improve it. The data burst grew more complex. In August, Voyager sent a packet containing executable code. Not NASA's, not human. When run in a quantum simulator, it generated a model of Earth's communication networks, mapping satellites, data hubs, even undersea cables with eerie accuracy. More disturbingly, it predicted failures in 3 global systems: a Japanese weather satellite, a Russian navigation array, and a private 5G network in North America. Each failure occurred exactly as predicted, down to the second, days after the data was received. The code wasn't just observing, it was interacting, probing vulnerabilities in our infrastructure. Voyager had become a relay, a node in a system far larger and more advanced than anything we could build. Then came the discovery beneath our feet. Neutrino detectors in Greenland picked up a faint, rhythmic pulse originating not from space but from deep within Earth, under the Arctic ice. The pulses matched Voyager's signal, beat for beat, despite no physical connection. Using seismic imaging, researchers found a structure buried beneath the ice, a vast geometric cavity with edges too precise for natural formation. It emitted low-frequency electromagnetic waves, perfectly aligned with Voyager's triple waveform signature. Deep within the structure, sensors detected heat patterns that followed the same golden ratio as the signal's visual lattice. And then faintly a sound. Not organic, not mechanical, but a hybrid resonance, like a machine humming in harmony with a living thing. The frequency matched Voyager's latest transmission exactly. The final event occurred at the Very Large Array in New Mexico. During a routine scan of Voyager's corridor, the telescope shut down for 43 seconds. When they rebooted, their logs were empty, except for a single audio fragment, 3.1 seconds long. It wasn't static or cosmic background noise. It was a chorus, layered, harmonic, voices that weren't human, but carried the cadence of speech. They didn't speak words but conveyed meaning, a sense of urgency, of warning. Analysts who heard it described a visceral reaction, a feeling of being watched, not from above but from within. One physicist, speaking anonymously, said it wasn't a message but a signal flare, a call to attention. Something had noticed us, and it wasn't just speaking, it was reshaping the conversation. Voyager 2 was sent to explore, to carry our voice into the stars, a testament to our curiosity and our hope. But now it's no longer just our messenger, it's a conduit, a bridge between our world and something vast, something that knows us better than we know ourselves. Its signals rewrite our code, mirror our systems, pulse beneath our ice, and sing through our stars. This isn't contact in the way we imagined. Not a handshake, not a greeting, but an integration. Something is using Voyager to map us, to test us, to prepare us. The triple waveform, the golden ratio lattice, the voices in the void, they're not just data points. They're a framework, a blueprint for something we can't yet comprehend. Voyager didn't find a civilization or a signal. It found a system, one that's been watching, waiting, and now responding. And the question isn't whether we're alone, it's whether we're ready for what's already here.